One feature that you use a lot in Scala programming that you might not have used in your previous programming experience is lambda expressions, also called closures, assuming it fits, in the case of Scala it does, or function literals. Now the syntax of these can vary. For example, in Python you actually use the keyword lambda to define these. In Java, starting with Java 8, they have lambda expressions. In Scala, the syntax for these uses a symbol that's an equals and a greater than, and we refer to this as rocket when we're reading the code. The idea of a lambda expression is it is a short literal expression that defines a function, and typically these should not be overly long. So for example, I could define a function for squaring values that looks something like this. Now the way I'm going to write this first, Scala is going to be unhappy with it. Okay, so the rocket here is basically showing us we have arguments on this side, and it is going to some expression over on the other side, and so x goes to x squared. Now you might wonder, well, why wouldn't I just do def square of x is a double? You can, though technically this is a method. This is a method of the object hello world. It's not really a function. Also, there are lots of places in Scala where we are going to write functions that we're actually not going to give names to. They're just going to be something that's small. We use them once. We don't need to use them multiple times. And writing defs for them is a little bit heavy-handed. Turns out you can use methods in the places that want to have functions passed in. So the distinction between them isn't all that strong. Now what is Scala unhappy about here? The problem is type. Okay, it needs to know what this input argument type is. And so in order to make this one happy, one way we could do that is to put a type on this. I put parentheses around this so that the argument, to enclose the argument. If I had multiple arguments, for example, if this was an x times y, I would need to put both of those inside of parentheses as well. But this is the argument list for the function. This is the body of the function. In this case, Scala can't figure out the type. Now, it turns out that most of the time we're going to be using these, and you will see we will use these a lot just in some of the upcoming videos. Most of the time when you use them, Scala can actually figure out the type. So you will very rarely have to put a type annotation in your lambda expressions. But this particular situation, we have to. And you would call this just like you would expect to call a function. So I can call square, I'm not sure, I guess that's valid number 2, square of 23, and this should print out that value. So the syntax for calling this is just like what you'd expect for any normal function, but this type of thing can go anywhere in the code to define functions for you. I can also define the type instead of putting it there. If Scala had more information, it could figure out the type of x. So I could actually specify the type of square. Square is a function that takes a double and goes to a double. How do we write that as a type? Well, it turns out we use the rocket for that. And it looks like this. So I say that square has the type double double, and then this lambda expression doesn't need the type annotation. As I said earlier, this is the situation you will normally run into. You would only have to type in this because Scala will be able to figure out the rest of the type information for you. There's also an alternate syntax that you can use, and I will use this a lot. I find it very handy. It only works in certain situations though, and that is an underscore syntax. So instead of doing square, I like to use the example of a function that takes an input and multiplies it by 2. Okay. We're going to do this with doubles, so its type is double rocket double. Now I could write this as x rocket x times 2. That's perfectly happy, but it turns out that if you only have if each argument, and this can be done with multiple arguments, so I'll show you that in just a second, if each argument only appears once, you can say this instead. Whoop. So I can say underscore times 2, which I would read as something times 2. The underscore is just a placeholder for us. If we want, we can space that out. This type of shorthand is really helpful for a lot of little things. Places where I would often use it is I want to do comparison. So a function, I'll call it LT, for short for less than. What LT is going to do is it's going to take two numbers, a double and a double, and it's going to give us back a Boolean telling us if the first value is less than the second value. I could write that as x, y, rocket, x less than y, but that's a bit verbose. A lot of times I will simply write this as underscore less than underscore. Oh, I put a rocket on there. Okay. I'm like, why is that unhappy? I'll pass these into a lot of comparison things. There are many places through this course where we will want to have the ability to pass in comparison functions, and so this type of shortened syntax will be very useful for that. X, y, we cannot use this for the x squared because my one argument appears 2 times, and the underscore syntax doesn't do that. If you said underscore times underscore, Scala thinks that should be x times y, not x times x. So when I need to use x twice, I have to go to the rocket notation. Most of the time, though, I actually prefer the underscore notation just because of its brevity, and I actually think it can be easier to read in a lot of situations as well.